Hello viewers, welcome to this last session on carboxylic acid derivatives. In our today's session, we will first review what we had done in our previous session, and then we shall talk about the methods of preparation, reactions and important uses of esters. In our previous session, we have discussed that carboxylic acids which contain this functional group COOH, their OH group can be replaced by some other groups and we get a set of compounds which are classified as carboxylic derivatives. When this OH is substituted by Cl, we call them as acid chlorides. When it is substituted by some amine group, we call them amides. When it is another alcohol group, they are known as esters, and when it is another acid, they are known as acid anhydrides. In our previous session, we have discussed about the methods of preparation and properties of acid chlorides, amides and acid anhydrides. We had also discussed their reactivity order and we compared their stability. We found there that in these compounds, the basic reaction, which is nucleophilic substitution, occurs at a very fast rate in acid chlorides because chloride Cl minus is a very good leaving group, whereas amides are the least reactive compounds because this NH2 minus is the poor leaving group. The reactivity of esters and anhydrides come in between. We also studied there that acid chlorides can be converted into all other acid derivatives. As today we are going to discuss esters, and esters are less reactive than acid chlorides and acid anhydrides. So they can be obtained from both of these, but they cannot be obtained from amides because they are more reactive from amides. So let us discuss first the methods for the preparation of esters. The very first method, that esters can be obtained from carboxylic acids. Now carboxylic acids and alcohol, they react and they lose a water molecule, we get ester. The reaction is carried out in presence of some acid. Generally few drops of sulfuric acid are used as catalyst in this reaction. For example, ethanoic acid, when it reacts with ethanol, it loses a water molecule and we get ethyl ethanoate. This reaction again is a sort of nucleophilic substitution reaction where this alcohol is attacking this carbon and OH is displaced. But OH itself cannot be displaced because OH is a stronger base. So this reaction is catalyzed with the presence of some acid, H plus ions. The reaction proceeds like this, that first this acid gets protonated with the H plus ions. The protonation occurs here. This oxygen acquires positive charge. Now this ethanol molecule, which although is a weak nucleophile, but now due to positive charge on this carbon, the residual positive charge on this carbon is enhanced, and this attacks here. This pi electrons shift to this oxygen and we get this situation. Now this sp2 hybridized carbon has been converted into sp3 hybridized carbon here. This is one OH, this one, and this is the OH which was here, and this is the ethanol molecule that is added here. Now this oxygen of the ethanol has got positive charge, it loses H plus and we get this sp3 hybridized situation where carbon has got 4 groups attached to it, and again H plus may add to any of these oxygens. If it goes to this oxygen, we are getting the structure before it. If it goes to this oxygen or this oxygen, we get this situation, that this oxygen acquires the positive charge. Now this molecule may lose a water molecule and again get converted into the sp2 hybridized carbon. So, water is lost like this and pair of electron from the oxygen shifts between this carbon and oxygen. So, this carbon oxygen acquires double bond, and now this positively charged oxygen has got attached one hydrogen, it loses again one H plus ion and we get this ester molecule. So, basically what has happened, one molecule of acid has reacted with one molecule of alcohol, one molecule of water is lost and ester is produced here. You see, in this sequence of reactions, all the arrows have been shown which are equilibrium arrows. Actually, every step is in equilibrium. So, this is an equilibrium reaction, and this reaction from this side to this side will proceed only if this water is constantly removed from the reaction mixture. If water remains there and acid as a catalyst is already there, so reverse reaction is equally probable. And if we take 1:1 ratio of this acid and alcohol, then 100% conversion to ester will not be possible. Reaction will stop at an equilibrium stage. So, in order to get the maximum yield of the esters, reaction should be carried out under such conditions so that this water is removed from the reaction mixture constantly, or one of the reactant, that is either acid or alcohol, is taken in large excess, so that according to Le-Chatelier principle we get maximum yield of the ester. Second thing about this reaction, when we try to break this ester molecule back into acid and alcohol, that is we call it as hydrolysis, that is with the help of water. Again, if the reaction is acid catalyzed, all the same steps are followed, only thing is in the reverse order. That is, there our starting material is this ester and our products are acid and alcohol. So, reaction proceeds in the reverse order when we carry out hydrolysis in acidic medium. We will discuss it little later. Then another method for the preparation of ester is that they can be obtained from alcohols or phenols using acid chlorides. A molecule of HCl is to be removed here, and for that we need a base like pyridine or other tertiary amines. They are used as catalyst, they take away this HCl and esters are formed. Even phenols will react with acid chlorides and we will get corresponding esters, such as phenol reacts with this acetyl chloride to give phenyl acetate or phenyl ethanoate. Then another example of this preparation of ester from acid chloride, that we can have even aromatic acid chloride also. They will react with alcohol like ethanol, and then in that case we will get ethyl benzoate. This is cyclohexane carbonyl chloride that reacts with the alcohol, and again we get the corresponding ester. So, all sorts of acid chloride, they can react with alcohols or phenols and we will get corresponding esters. The reaction involves the loss of one HCl molecule and it is assisted with the presence of some base which may be a tertiary amine or pyridine. Then we can get esters from alcohols or phenols using acid anhydrides also. Acid anhydrides react with alcohols or phenols and a molecule of acid is to be eliminated. This alcohol part goes with the one of the acyl part and other goes as acid molecule. This reaction is also assisted with the presence of few drops of concentrated sulfuric acid. For example, salicylic acid is a phenol can form the corresponding ester using acetic anhydride in presence of sulfuric acid. We get this compound which is named as acetyl salicylic acid. The acetylation of this hydroxyl has occurred using acetic anhydride and this is used as a medicine called aspirin. Esters can also be obtained from silver salts of carboxylic acids. There the silver salts of carboxylic acids are treated with alkyl bromide, such as on treatment with methyl bromide, silver acetate, it forms methyl acetate. This reaction involves simply the loss of this silver from the salt and bromide from the alkyl bromide or alkyl halide, and corresponding silver bromide is formed. Then ethers can also be converted into esters. This is not very general reaction because this requires very drastic conditions, but industrially it is used. Ethers undergo condensation with carbon monoxide. Boron trifluoride is used as a catalyst. The temperature is generally between 125 to 180 degrees Celsius, but the pressure is very high, almost at a 500 atmospheric pressure. They undergo this reaction and we get these esters. Basically what has happened in this reaction, to this carbon monoxide on the carbon, one alkyl and one alkoxide, these groups have added across the carbon of the carbon monoxide. So one R here, one OR here, and we get ester molecule. Esters are also produced from aldehydes by a specific name reaction which is called Tishankov reaction. Tishankov reaction is related to Cannizzaro reaction. If you remember, Cannizzaro reaction is given by those aldehydes which do not contain any alpha hydrogen, and on treatment with alkali, one of the aldehyde molecule is oxidized to corresponding acid and another molecule is reduced into corresponding alcohol. In Tishankov reaction, this reaction is carried out in a non-aqueous medium. The catalyst used here is aluminium alkoxide, generally aluminium ethoxide is used. Say ethanol, when it is heated with aluminium alkoxide, we get ethyl ethanoate. Actually, how it is related with the Cannizzaro reaction, if we look at the structure of this ester, it is that ester which is formed in this reaction which might have been formed by the two products obtained in the Cannizzaro reaction of ethanol. Ethanol and Cannizzaro reaction will give you ethanoic acid and the reduced product will be ethanol, and those ethanoic acid and ethanol will combine to give this ester, ethyl ethanoate. In this reaction directly those ethanoates, those esters are produced. Then there is a specific method which is used only for the preparation of methyl esters. The reagent used is diazomethane. Carboxylic acids, they undergo reaction with diazomethane where a methyl group gets introduced on the oxygen. Basically it is CH2 from the diazomethane which is being introduced in between the OH bond. This bond breaks and we get OCH3 and nitrogen is lost. So these are various methods by which we can obtain esters. Now let us talk about their some of important reactions. As we have discussed earlier that these acid derivatives, they undergo nucleophilic substitution reactions. Nucleophiles, they attack on this carbonyl and this group is lost. And we have also discussed only those nucleophiles will be able to replace this group where this group is a weaker base. So in the series, reactivity series of these acid derivatives, as I discussed earlier also, that esters are more reactive than anhydrides and acid chlorides. So they cannot be converted into acid chloride and acid anhydrides. They can be converted into amides or they can be hydrolyzed into corresponding acids. So let us start with the hydrolysis reaction. These esters, they get hydrolyzed. This hydrolysis can be in acidic medium as well as in basic medium, and we will get corresponding acid and alcohol. If reaction is carried out in alkaline medium, obviously ultimately it will require acidification so that the anion of the acid which is formed gets converted into the acid. The hydrolysis in alkaline medium is also known as saponification because it is the same reaction which is used for the preparation of soap from oils. Oils are also esters. Now there are various mechanisms for the hydrolysis of esters. So let us discuss these mechanisms. Now first thing we can say that this ester hydrolysis can be either acid catalyzed or base catalyzed. Second, it may involve the cleavage of acyl oxygen bond or alkyl oxygen bond. What do you mean by acyl oxygen bond? Let us see. This is the structure of an ester. This is RCO. This is the acyl part. And if this bond with the oxygen of this ester, if this bond is cleaved during the reaction, we call it as acyl oxygen cleavage. And if during the reaction this bond cleaves, that is the alkyl part with the oxygen, then we call it as alkyl oxygen cleavage. There is a possibility of cleavage of both the bonds. So, there can be again different reaction here. And third, reaction may be unimolecular or bimolecular depending upon the kinetics of the reaction. So, there are three factors involved: catalyzed, acid or base catalyzed, cleavage may be this acyl oxygen cleavage or alkyl oxygen cleavage, reaction may be unimolecular or bimolecular. So, taking all the three factors into considerations, 2 into 2 into 2, there are 8 possible mechanisms for ester hydrolysis, and these are those 8 possible mechanisms. They have been symbolized like this. I will explain it. Say capital A, then AC written as subscript and then 1. This capital A indicates acid catalyzed. Then AC, this indicates acyl cleavage, acyl oxygen cleavage, generally called acyl cleavage, and then 1 represents the molecularity of the reaction, unimolecular. So, if a reaction is acid catalyzed involving the acyl oxygen cleavage and follows a unimolecular kinetics, then it will be symbolized as AAC1. Similarly, if it is a bimolecular, AAC2. If the reaction is acid catalyzed and involving an alkyl cleavage and unimolecular, it will be symbolized as AAL1, and if it is bimolecular, then AAL2. And similarly, all these 4 situations of acyl or alkyl cleavage and unimolecular, bimolecular, when they are base catalyzed, then the first letter is capital B, written like this: BAC1, BAC2, BAL1 and BAL2. Means BAL2 stands for base catalyzed alkyl cleavage bimolecular. Now, there are 8 possible mechanisms, but these are all not the general mechanisms. Out of these 8, there are 2 mechanisms: one acid catalyzed, it is acid catalyzed acyl cleavage bimolecular, and one base catalyzed acyl cleavage bimolecular. These 2 are very commonly observed when we adjust the condition as acid or basic condition. Other mechanisms are observed only in very specific cases. So, we are not going to discuss all these 8 mechanisms. I will take up these 2 common mechanisms and then 2 specific cases where other mechanism of these are used up. Let us first take up acid catalyzed acyl cleavage bimolecular. That is the most common acid catalyzed mechanism, and as I said earlier, this is opposite to the formation of esters in presence of acid. So, steps are exactly in the reverse order that we had discussed for the formation of esters. Now, this is ester. The first step is protonation. Protonation occurs on this oxygen and then it is attacked by water molecule. Water molecule attacks this carbon because the positive charge on this carbon is enhanced due to this positive charge on the oxygen. So, this water molecule attacks here, this pair of electron shifts to oxygen. Then we have now again this sp3 hybridized carbon where one alkyl group is there, 2 hydroxyls are there, 1 alkoxy group is there. The positive charge is now on this oxygen, that was from water. This loses 1 H plus ion. We get this sp3 hybridized carbon state with all the 4 groups without any charge, and then again proton may add. Now, it may add on to the oxygen of the OH group, we will get this structure, but if it goes to the alkoxyl part, oxygen of alcohol, then we get this structure. And if it is here, this may lose the molecule of ethanol because it is a very weak base. The pair of electrons shifts from here and then it shifts there. We get this situation. It is again an sp2 hybridized carbon being formed here. This loses one H plus and we get the molecule of acid. So, one ester has been cleaved into acid and alcohol. The driving force for this reaction in the forward direction is excess of water. As I said, for that synthesis, either water must be removed or one of the reagents should be in excess. Now, water is here in this particular case is one of the reagents. So, if there is excess of water, reaction will be in this direction, that is esters are hydrolyzed into acids to completion. Then base catalyzed acyl cleavage bimolecular reaction BAC2. This reaction involves these steps. This is an ester, say we have taken methyl ethanoate. Hydroxide ion, which is a strong base, attacks this carbon and this pair of electrons shifts to oxygen. When these electrons come back now, a methoxide ion is lost. So, we have got now this acid and a methoxide ion. Methoxide is a much stronger base than this acid. So, there is an immediately transfer of one H from here to here. So, we actually obtain this carboxylate anion and the alcohol part, and this carboxylate anion is ultimately converted into carboxylic acid when finally we acidify for workup of the reaction. Out of those 8 possible reactions, I shall take up 2 examples which are observed in some specific cases. One of them is acid catalyzed alkyl cleavage unimolecular, that is reaction involving the alkyl cleavage in ester and it is acid catalyzed. This reaction is observed generally in those esters where the alcohol part has got such an alkyl group which can form a stable carbocation, like it is a tertiary butyl group here, it can be a benzyl or some allyl group also. Then in such cases, when we try to treat the reaction with acid, the protonation occurs immediately here, and then this group which can form a stable carbocation is lost as carbocation part. This pair of electron comes here, we get this acid and a stable tertiary carbocation here. This reaction is favored the polar solvents. Second thing, as I said, alcohol part, this alkyl part on the alcohol side should be such a group that it can form a stable carbocation. And here you see this is the first order reaction because protonation is an equilibrium step. Without assistance of any other thing, this molecule is being cleaved and it is lost as carbocation. This acid is a leaving group. Now, if we compare this reaction with the SN1 reaction which we discuss in alkyl halides, where if alkyl group is such that it gives a more stable carbocation, then it is favored for SN1 mechanism. It is the same thing here. The leaving group is a very weak base, it is an acid here. Then another mechanism for which we have few examples is base catalyzed, again involving alkyl cleavage and is bimolecular. This reaction is generally observed in such cases where base is very strong and our ester is such that it is causing some steric hindrance on this carbon, that is on this side bulky groups are there. So, now this alkoxide group instead of attacking this carbon can also attack this carbon and this bond cleaves and this group is lost. So, this benzoate ion is lost here and we get ether. It is exactly similar to SN2 type of reaction that we have discussed in alkyl halides, that where very strong nucleophile attacks the carbon, but it will preferably attack those carbon which are generally primary or less substituted. So, this is simple methyl group. Under such situation, when this group is bigger one and can leave, then strong bases attack here. So, this is a sort of SN2 reaction going on and we get this ether and this is the acid part. Then ammonolysis. Ammonolysis we have discussed earlier, the reaction when molecule is cleaved with the help of ammonia. Esters, they get cleaved with the help of ammonia, ammonia acting as nucleophile here, and we get amide and alcohol. If in place of ammonia we use some other amine, then we call that reaction as aminolysis. Basically we get amides, but when some amine is used we get secondary or tertiary amides, such as in this ester when I am using a methyl amine here, we get N-methyl ester. So it is a secondary amide. So we call this reaction as aminolysis. Transesterification. This is a reaction in which one of the ester is converted into another ester by the exchange of alcohol. Means when one ester is treated with some different alcohol, the alcohol parts they get exchanged and another ester is formed. This is also an equilibrium reaction, and this reaction can be catalyzed with acid as well as by base. And these days this reaction has got very good industrial application. Using this reaction we are preparing biodiesel from those oils or fats which are not edible. Oils and fats, you know, are the esters of glycerol with long chain fatty acids. This CH2, CH, CH2, OH, 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 this is a 3 carbon alcohol called glycerol, and oils and fats are the esters at these 3 hydroxyl groups. This R1, R2 and R3, they represent very long carbon chains, generally 12 to 18 carbon chains. When this is treated with methanol, as I said, transesterification can be catalyzed with acid as well as base. Here base is used but no water is used, because if water is there, they will be simply hydrolyzed. So say with methanol, then they get hydrolyzed, they get rather cleaved, and methanol now forms the ester with these acids. So we get the methyl esters of these long chain fatty acids and glycerol, and these long chain fatty acid methyl esters, they are used as diesel. We call it as biodiesel. And since we know that there is a demand for such compounds, such substitute, we can replace the existing fuels that we are getting from nature. So biodiesel is taking the place in that. Then reduction. Esters are reduced with lithium aluminum hydride. Lithium aluminum hydride cleaves this bond, CO and O bond. One H goes to this oxygen, one H goes to this carbon. So this side goes as aldehyde and this side goes as alcohol. And aldehydes get further reduced with this lithium aluminum hydride, and we ultimately get 2 molecules of alcohol. One, the alcohol that was the part of the ester, and the other, the acid part of the ester, is also reduced into corresponding alcohol, such as ethyl benzoate. When it is reduced with lithium aluminum hydride, we will get ethyl alcohol, that is ethanol, and benzyl alcohol from this side. Then there is another reaction called Claisen condensation. Claisen condensation is related to aldol condensation. We have discussed this aldol condensation in aldehydes, and given by those aldehydes are ketones which have alpha hydrogen. This Claisen condensation is also given by those esters which have alpha hydrogen. The reaction involves the treatment with a strong base like sodium ethoxide, sodium alkoxides are used. Ethyl acetate, when it is treated with sodium ethoxide, we get ethyl acetoacetate. In this reaction, the beta keto esters are formed. This reaction proceeds like this, that alpha hydrogen from one of the ester molecule is lost, that is from here we will get CH2 minus. This anion is formed, and this anion attacks the carbonyl carbon of another ester molecule with the loss of this alkoxide ion. So ultimately we get these beta keto esters. If we take mixture of 2 different esters and both are having alpha hydrogen, then there is a possibility of formation of 4 products, because each of the ester will form its anion and it can react with another similar molecule or the different molecule. So we call that reaction as crossed Claisen condensation. say when this Crossclaisen condensation is carried out between ethyl acetate and ethyl propionate. These are the 4 possible products. This is ethyl acetoacetate, this is ethyl propioacetate. Here this is formed when the anion from the ethyl acetate has attacked the carbonyl group of ethyl propionate. Then this is the compound formed by the reaction of anion obtained from ethyl propionate, because the anion will be formed at this carbon, this is the alpha carbon. So, this anion will attack the carbonyl of this. So, 1-methyl will come as a substituent here in the chain, and then this is the compound formed by the attack of the anion of ethyl propionate on the another ethyl propionate molecule. So, these were some basic reactions of esters. Now, let us discuss some uses of esters. Esters occur naturally in plants and animals. They have sweet fruity smell, and different esters in combination with other volatile compounds produce the pleasant aroma of fruits. Hence, they are used as food additives and also in cosmetics. This table gives you the aroma or fragrances of different fruits from different esters. This is propyl acetate, has the fragrance of pears, then octyl acetate oranges, isoamyl acetate banana, ethyl butyrate pineapple, ethyl acetate apple, and methyl transcinnamate, means the methyl ester of transcinnamic acid has the smell of strawberry. Then these esters are used as solvents in lotions, nail polish removers, glues, and they are also used as solvent in many organic reactions. Many esters are used as monomers for the preparation of polymers. For example, plexiglass is a polymer. Its monomer is methyl methacrylate, and this polymer is used for making bulletproof screens and windscreens of aeroplanes. It is transparent but very hard plastic. Then polymers like terylene are polyesters. It is also known as PET, polyethylene terephthalate, and it is used for making containers, conveyor belts, and waterproof fabric. Fats and oils are also esters, and they are used for production of soaps. Then some common medicines like aspirin, methyl salicylate, procaine, benzocaine, etc. are also esters. So, what we find that esters are very useful to us. They are used in different fields. So, let us summarize what we have done today. Today we discussed the important methods for the preparation of esters, that esters can be obtained from carboxylic acid directly, from acid chlorides as well as from acid anhydrides. They are also obtained from aldehydes by Tischenko reaction or by the addition of carbon monoxide to carboxylic acids. Then we discussed their important properties, including ester hydrolysis, then ammonolysis, and we also discussed the mechanism for the hydrolysis. Then we had discussed some important uses of esters. Now, during these 3 lectures on the acid derivatives, we had discussed that carboxylic acids can be converted into 4 main acid derivatives, that is acid chlorides, amides, esters and anhydrides. We have discussed the relative stability and reactivity of these compounds, and we found that acid chlorides are most reactive and they can be obtained only from acids, but they can be converted into all other acid derivatives. Where acid amides are the least reactive, they can be obtained from all other acid derivatives like acid chloride, anhydrides or esters, but they cannot be converted into any of those. The basic reaction which involves in the interconversion of these is called as nucleophilic acyl substitution. That is the most important thing in the acid derivatives, their comparison and their reactivity. We have also discussed some other methods for the preparation of amides, anhydrides and esters and some important properties. We have seen that these acid derivatives are also subject to different use in our daily life. Hope you have enjoyed this series. Thank you.